Hello everyone, welcome to lesson 8-3, volume of spheres. In this lesson we will use vocabulary such as sphere and hemisphere. Okay, let's describe what a sphere is. Now when we think about a sphere, the first thought that should come to mind is a ball or a globe, right? But technically speaking, a sphere is a set of all points in space that are a given distance, known as the radius, from a given point known as the center. So the radius is the distance to the edge of the circle, okay? But because it is given in any point in all 360 degrees, vertically, horizontally, and in any angle, any given point, we know it as the center. So now that you know the technical term, let's describe the shape of the cross section. So the shape of the cross section right here, okay? What shape would that give us? That would give us a circle. Now name this part of the spheres. This part, the center part. That part of the sphere is the radius. Okay, and name this part of the sphere right in the center, right there, right? We simply call it the center. And then name the two examples of a sphere. So like I mentioned, a ball, so it could be a basketball, or it could be a planet, or a satellite like the moon. So a basketball or the moon would be examples of a sphere. Let's connect it to a real world connection. Brittany purchased a necklace that contained a round pearl with a diameter of 7.5 millimeters. What is the circumference of the largest circle around the outside of the pearl? Round to the nearest tenth. In order to solve this, we have to think back to what the formula for circumference is, because that's what they're asking us. What is the circumference? And they're giving us a diameter, right? A diameter right there, a diameter of 7.5 millimeters. So let's use the equation. So a circumference is equal to the diameter times pi, or pi times the diameter, right? So when we replace our variables, the circumference is equal to 3.14 times 7.5, and that would give me circumference equals 23.55, or if we round, we would just simply write to the nearest tenth, 23.6, and that's millimeters. So now that we practiced finding the circumference, we can talk about volume of a sphere. In words, the volume, represented by the variable v, of a sphere is 4/3 the product of pi and the cube of the radius. The cube of the radius, not the square like we do area. This would be the cube, since we are looking for a three-dimensional figure, which would be exponentially 1 greater than area. So volume is equal to 4/3 of pi radius cubed. Interesting. You can use the formula for the volume of a sphere to solve mathematical and real-world problems, and that's just what we're going to look at. Here's example 1, where we're simply going to replace the variables into this formula. We have a radius of 6 millimeters, so we just simply replace our radius with 6, we cube it, 6 times 6 times 6, right? Then we multiply by pi, 3.14, and then we multiply by 4/3, which you could also write as 1 1/3, sorry. Because if you wanted to convert it into a decimal, you have 4/3, and you have to ask yourself how many 3's are in 4. You have 1, and you have 1 left over from 3 to 4, all over 3, and 1 1/3 is 1.3 bar notation. So we can use that number right there to replace this factor. So now that you know that, go ahead and solve A and B here. Now remember, we are looking for the volume is equal to 4/3, or 1 in 1.3 bar notation, times pi times radius cubed. There's your formula. Go ahead and solve A and B. Pause now. Okay, I hope you paused the video. I'm going to jump ahead and pretend I already wrote down the formula and just simply replace the variables with the information given. I have volume equals 4/3 of pi, which is 3.14, times radius, which would be half of the diameter, so half of 22 is 11 cubed. Now volume equals 4/3 times 3.14, and we have to solve for our exponent according to order of operation, and 11 cubed is 1,331. Now we multiply that times 3.14 times 1.333 bar notation, and I get volume equals 572.453, or just simply 572.5 to round to the nearest tenth, as they mentioned up here. See that? So that is the volume, and that is in centimeters cubed. Remember that it's cubed because we are talking about a three-dimensional figure. Okay, again for B, I'll do the same. I will just replace my variables as I go. Volume equals 4/3 times 3.14 times 5 cubed. Volume equals 4/3 times 3.14 times 125. 5 times 5 times 5 is 125. And volume equals 523.598, which to the nearest tenth would become 523.6. And this one's millimeters cubed. Don't forget your units. Now let's see how this applies to a real world scenario. A spherical stone in the courtyard of the National Museum of Costa Rica has a diameter of about 8 feet. Find the volume of the spherical stone, round to the nearest tenth. So diameter of 8 feet, which equals a radius of 4, right? Radius half the diameter. So I'm ready to insert that in there. Radius, replace it with 4, and simply multiply directly across after you solve for your exponent, and you get 268.1 cubic feet. So now we try it. A dish contains a spherical scoop of vanilla ice cream with a radius of 1.2 inches. Ooh, nice big spoonful of vanilla ice cream, or a scoop I should say. 1.2 inches, so that's our radius. We don't have to, it's not the diameter, so we don't have to divide it in half. It's given to us. What is the volume of the ice cream? Okay, let's write down the formula. And I jumped ahead and wrote pi as the decimal already. And now let's replace our radius. And when I solve for the exponent, I get 1.728. And now I can just simply multiply straight across, right? So I'm going to multiply, I'll go backwards because I already have this value in my calculator. So now I just have to multiply that times 3.14. So I type in times 3.14 times 1.3 bar notation. And that equals 7.234. Well, those 3 and 4 are not going to change my 2 because they're not above 50. So it's just simply 7, let me erase that. 7.2, and our units are inches. So it would be inches cubed. Okay, I hope you got that right. Example 3. A volleyball has a diameter of 10 inches. Okay, diameter, so our radius must be half of that, which is 5. A pump can inflate the ball at a rate of 235 cubic inches per minute. How long will it take to inflate the ball? Round to the nearest tenth. So our unit is minute. So I guess we have to find the overall amount, the overall volume, and then divide it by this number, right? 325 cubic inches, because that's how many it's per minute, and that'll give us our number of minutes. And you can see there that that's exactly what they're doing. Okay. They identify the rate of 325 per minute, and then inches, and then this is how many inches. Or we could have simply just taken this value and divided it by this value, and we would have gotten this value. But I can show you that on my example. Feel free to pause the video at this point and follow the steps the way they did it, and make sure to read the blue text going along so you can identify the steps. And now let's try it together. Okay, let's read it together, and if once we've read it, if you think you can do it on your own, pause the video. A snowball has a diameter of 6 centimeters, radius of half of that, which is 3. How long would it take the snowball to melt if it melts at a rate of 1.8 cubic centimeters per minute? Okay, so 1.8, that's our rate per minute, round to the nearest tenth. All right, first we have to find out what's the volume, right? So volume equals 4 over 3 pi r cubed. Volume equals 4 over 3 times pi. And my radius is 3 cubed, which 3 times 3 times 3 is 27. I'm just going to go ahead and erase that. Just jump right to 27, so I don't have to write it all over again. Okay, I know that you're able to follow along. 27. And now I can go ahead and multiply all together. So the way I do it, let me show you. I take my calculator and I'm going to write 4/3. The way I write 4/3 is I write the 4, I choose the 4 first, and then I choose over or divided by 3. So 4 over 3 is simply like saying 4 divided by 3. And that gives me my decimal version of 4/3. Right? You can say 1 1/3 or 1.3 bar notation. Now that I have that, I'm going to multiply that by pi. So I can just simply go times 3.14, or you could have pressed times and then the pi option right there where you see my finger at the tip of it, right there, pi. You can kind of see it right there. Okay, but I just did 3.14. Then I multiply that by 27, right? Because it says 27 right here, right? Then I will equal that. That's my volume. That's my volume of the ball, the snowball. And now I need to, as it says right here, let me move it over. I want to identify how many minutes are in that. But it says it's 1.8 cubic, what is it, 1.8 cubic what? Centimeter per minute. So I have to divide it by 1.8. So I go again, divide by 1.8, and I get 62.8. So that's 62 minutes. I can stop this now. Okay, that is 62.8 minutes. That's how long it would take for the snowball to melt. So therefore it would take 62 minutes for the snowball to melt. And finally, let's start looking at half, okay, by analyzing a hemisphere. Volume of a hemisphere. A circle separates a sphere into 2 congruent halves, each called a hemisphere. So if you could take the globe and cut it exactly in half, you would have the southern hemisphere and the northern hemisphere. Well, right now we're only looking at the bottom half, which is the southern hemisphere. Find the volume of the hemisphere, round to the nearest tenth. So it's exactly the volume, the formula for volume, except now we're multiplying it by half, so that we can get half of this number. Whatever number we get here, if we multiply it by half, we'll get half of that number. And you can see they're following the formula of the sphere normally, see, a 5 radius. They multiply all that and then multiply it by half, or you can simply divide by 2 if you want. And you will get your volume of a hemisphere. And now we can try it. Here we have E and F with a diameter of 2 on this one, diameter of 2 centimeters, and a radius of 9. Now this would be a radius of 1 centimeter, okay? Because remember, they're giving you the whole line. So let's write down our formulas first. Remember that its volume equals half of the volume of a sphere, 4/3 times pi times radius cubed. And let's write it again right here. Okay, and now we can start replacing variables. Now this is going to be easy, simply because we could just multiply times 1, and 1 times 1 times 1 is 1. So essentially what we're doing is we're multiplying these two together and then multiplying that times a half. So that should be relatively quickly. Or I'm going to write volume equals a half times 4.3 times 3.14, and that's it. Like I mentioned earlier, if we replace that with a 1 times 1 times 1 is simply 1, and 1 times pi is pi, and it's identity, right? Multiplication, property of identity. So here we have volume equals 2.09, which would round to the nearest tenth as 2.1 centimeters cubed. Okay, let's go to the next one. Volume equals a half times 4/3 times 0.1314 pi times 9 cubed times 9. Oh my goodness. Which is 729. And now we can multiply all three together and then multiply that times a half. When I multiply just this area here for my full volume, I get 3,052.1. And then when I multiply that times a half, or simply divide it by 2, I get 1,526.04, or just 1,526 is fine. And that would be, I'll put the 0.4 because it round to the nearest tenth. And that would be meters cubed. Okay, that is it for today, everyone. See you next class.